The nearest stars are fascinating because they have been studied for so long that their properties are well known. You could say they're our cosmic neighbors. Let us take a quick glimpse of some of them. Proxima Centauri. The nearest star to our solar system is Proxima Centauri. It's a red dwarf, which means it's not massive enough to fuse hydrogen in its core, like our Sun does, and has a lifespan of approximately 10 trillion years. The distance between Proxima Centauri and Earth is about 1.3 light-years away. In other words, we would need to travel at the speed of light for over 4 years before reaching this star. A red dwarf like Proxima Centauri emits far less light than our Sun, so much so that it would appear as little more than a faint speck of light even if you are standing right next to it. Proxima Centauri also has another feature that makes it unique from most other stars in our galaxy: its flare activity. This means that occasionally there can be violent outbursts on or near the Sun's surface. The most oversized flares have been observed producing flares 100 times more intense than those made by our own Sun. Wolf 359. Wolf 359 is the most distant of all the stars we can see with our naked eyes without a telescope. It's about 7.8 light-years away, which means that if you're looking at it right now, and you are, you're also looking at what was happening in our solar system 7.8 years ago. The closest star to Earth after the Sun is Proxima Centauri, at 4.2 light-years away. That means that if we traveled at 1/100th of the speed of light, it would take us 4 hours to get there. Wolf 359 has been thoughtfully nicknamed Buffy because its surface temperature is too hot for life like ours. Around 2,300 degrees Kelvin, 4,700 degrees Fahrenheit, Buffy's mass and luminosity are like those of our Sun, so much so that scientists even suspect it might be part of an identical twin. It also has an age closer to ours than other red dwarfs, about 3 billion years old versus 12 billion for Proxima Centauri and 40 billion for Barnard's star, another nearby red dwarf not far from Buffy in terms of distance, but further away along its orbit around Sol. Lalande 21185. Lalande 21185 is a red dwarf star about 8.5 light-years from Earth. It's like our Sun, but it has a planet called Lalande 21185b. This planet is about the same size as Earth and orbits its host star in just over 9 days. Epsilon Eridani. Another star that is reasonably close to Earth after the Sun is Epsilon Eridani. It's a binary system. One of the stars in this system is slightly larger than our Sun, while the other is smaller. That makes it a yellow dwarf. It has a surface temperature of 5,500 degrees Celsius, more than 10 times hotter than our own star, but it's cooler than other stars such as red dwarfs. Epsilon Eridani could be only 10.5 light-years away from Earth, which means that if you were to travel there at light speed, which we currently can't do, it would take only 10.5 years to get there. Its planet, HD 21749b, may have water on its surface and even life forms. 61 Cygni A. We have many reasons to be interested in this solar system. First, it's one of the closest, if not the closest star system to Earth we've discovered so far. Also, it contains 2 stars that orbit each other every 42 years, like our own Sun and its companion planets. The first star system discovered to have a planet is 61 Cygni A, a binary star system about 12 light-years from Earth. The primary star is 61 Cygni A, while its companion star is 61 Cygni AB. The two are red dwarfs, low-mass stars that are cooler than our Sun, but still emit enough energy for life as we know it on some planets orbiting them, such as Earth. Tau Ceti. Tau Ceti is a star that is 11.9 light-years from Earth. It's a G-type star and a yellow dwarf, which means it has roughly the same surface temperature as the Sun. The habitable zone of the Tau Ceti system sits between 0.8 to 1.4 AU astronomical units from its central star, which is equivalent to about 0.6 to 1 billion kilometers, or about 600 to 1,000 times closer than our current orbit around the Sun. Barnard star. Barnard star is the fourth closest star system to Earth. It is located 5 light-years, 3.1 parsecs away, towards the constellation of Ophiuchus. It has an apparent magnitude of 9.5, making it visible to the naked eye in dark skies. The star has a mass only 0.14 times that of our Sun, and a radius half as large, resulting in a luminosity 10% smaller than our Sun. Its metallicity is like that of Sol's. An abundance index near naught would suggest almost no metals or all metals, with iron being the most abundant metal, while an abundance index near 1 indicates all elements are present. Its effective temperature is 8,130 degrees Kelvin, with surface temperatures ranging from 7,730 to 8,570 Kelvin. The age of this red dwarf is estimated to be around 6 billion years. Groombridge 34AB. Groombridge 34AB is a binary system of 2 stars separated by only about 1.5 astronomical units, or about 1/7 the distance from the Sun to Mercury. The primary star, the larger of the two, is similar in mass, size, and luminosity to our Sun, while its smaller companion is around 1/3 as massive and emits only about 0.4% of its light output. This makes it a red dwarf star like Proxima Centauri, the nearest known star system to Earth. But Groombridge 34AB's red dwarf isn't quite as close as Proxima Centauri. In fact, this stellar pair would be considered part of Alpha Centauri if there weren't already 3 other stars in between them. UV Ceti. UV Ceti is a red dwarf star. Red dwarfs are small, long-lived stars that emit less radiation than other types of stars like yellow or blue supergiants. Red dwarfs can be up to 10 billion years old, but they don't become main sequence stars until they reach the age of 2 billion years. That's because they burn at lower temperatures than more prominent stars, which means that they are fainter in visible light and have a longer lifespan before reaching the end of their lives as white or black dwarfs. UV Ceti is an active flare star that regularly emits high-energy particles into space in bursts lasting from seconds to minutes. These flares are thought to be caused by magnetic fields interacting with the stellar wind, a stream of charged particles flowing out from its surface. UV Ceti also varies significantly over periods ranging from hours up through weeks. These variations happen because it has a strong magnetic field that causes intense flares and pulsations depending on where its poles face Earth at any given moment. There is a lot of cool stuff in our solar neighborhood. To learn more about these systems and the planets that orbit them, we must first understand how astronomers classify stars. We will find more exciting discoveries as we expand our reach and explore the unknown. However, as I have said before, it is essential not to forget about our cosmic neighbors in this process.